Hi, this is Professor Ash with a video lab on the ultrasonic sensor HC-SR04. This is a relatively simple sensor. It has an output and an input using ultrasonics. Pins that we're going to be using are a power, a ground, a trigger pin, and an echo pin. The way this works is very similar to the way a bat uses ultrasound to navigate. The trigger pin is going to send out a signal that the echo pin will then read when it comes back. The total distance traveled by that signal is 2 times the distance from the sensor to the object being measured. The way the sensor works, it's going to take the trigger pin low with the digital right, and then we're going to pause there. This allows the module to settle some. Then we're going to take the trigger pin high and leave it there for a short duration. And then we're going to take it low again. Then we will go back and read the echo pin and get a timing on the out of the echo pin. Okay. So the schematic is set up with a breadboard. I'm going to set mine up with wires directly to the Arduino, but you can definitely set it up on the breadboard as you wish as well. We'll use the code that's in the lab document. Okay, we're going to be setting the trigger pin up to pin 13, the echo pin to pin 11. Got 3 floats that we'll be tracking. One of them is a constant, the speed of sound in miles per hour, when the temperature is 77 degrees, so nominal temperatures. In our setup, we have to set the 2 pins for output and input appropriately, and we're going to be using the serial monitor, so we set that up. Our main loop goes through the sequence we just talked about, low, high, low on the trigger pin, and then we read the time off the echo pin. It's presented in microseconds. We're going to convert microseconds to seconds initially. That means we divide it by a million. Then we're going to divide by 3600 to take the seconds into hours. So we end up having a travel time in hours. Our speed of sound was in miles per hour, so we take time times the speed of sound and we get miles. We divide that by 2 to get the distance to the object instead of the distance to the object and back, but just the distance to the object. And then we're going to convert that distance in miles to inches using 63,360. We'll print the distance back out in inches. We'll wait 1/10 of a second, and then we'll repeat in our main loop. Relatively simple, straightforward code. Now here I've got my Uno. I've got pins 11 and 13 set up and pins power and ground. I'm going to take the ground first one I'll connected there. Then take my pin 11, which is going to be the echo pin. That goes to the echo pin. Then my trigger pin to trigger, and my power pin to power. Got all of those set up. Now I can plug in my power to my Arduino. Have this set up over here. I'll be using a clipboard to reflect the signal, and you'll see even this is not big enough when I get to a far enough distance out. Okay. And then I need to get my Arduino code, the code that was in there, set up into the Arduino. Run and compile that. Got an error there, try it again. There, it's uploading. And uploading. Now we'll go pull up the serial monitor. Serial monitor right now with nothing in front of it. It's reading a large number. It's not getting any echo. Put my clipboard down in front of it. I'm sitting about 8 inches away, move it back to about a foot, move it back into about 3 inches. And let's see how far out I can take it, how well I can keep this clipboard aligned so that the echo goes back to the sensor. I'm about 30 inches right now away, and I'm getting some variation depending on how I tilt it. So this clipboard is sending the echo off in different directions, and I can make it seem like it's a little longer. I think sometimes when I get 50, I'm probably sending it up off my monitor and then back down. So it can give me some erroneous measurements due to multiple reflections. But this right here, about 27, 28, is about how far I'm holding it right now. So I'm going to lift this up and I'm going to hold it, have it reflect off the door, and you'll hear my voice as I go back over here. So I've got it off my door. I'm sitting here right now about 20 inches away. I'm going to back up. And I've backed up as far as my cables will allow me from the door, and that's probably about that 50 inches is probably accurate on that. Okay. Now let's see if I go over to and do it off a part of my ceiling. Part of my ceiling, I'm right around 32, so I'm bringing it back down to the floor. $60, that's about 5 feet. I'm 2 feet off the ground. That's probably about right. 2 feet, 5 feet to the ceiling. So see if I get it all the way to the ground. I measure around 84 inches, and I do. That's about a 7-foot ceiling, maybe a little larger. So the device can work and reflect off pretty large things. If you're measuring something small, it's going to have issues if it's reflecting in different directions. And for you, the rest of your lesson, I'd like you to modify the program to add unit notation, so inches, so change the serial, make the serial print out also inches on the same line as the distance, and then post the video of that to your blog or lab report. Thank you.